Right, okay everyone. I got cut off then. I used up all my memory on my iPad, so I've just had to delete a lot of videos. And as you can see, I've continued without you a little bit. So we got to, didn't we, the electrons whizzing around, creating a little bit of energy, and that allows us to pump the hydrogen ions through these channels, through these proteins, so that we now have a really high concentration of hydrogen ions up here in the intermitochondrial space. Now, you'll be glad to know that's all you need to know for the electron transport chain, all right, the ETC. What we're going to do now is something called chemiosmosis. And actually, I'm going to leave that till Thursday, all right? I think you've had enough to take on board today. There's just one other thing that I want to point out to you, and that is that NAD, reduced NAD, when it drops its hydrogen atoms, it drops them at protein number 1, and the electrons jump on to protein number 1. Okay, and so they whiz around. FAD drops its electrons off at protein number 2, okay? And so they jump on to protein number 2 and go on to number 3 and number 4. Now, the reason, the consequence of this is that NAD produces a little bit more energy, reduced NAD produces a little bit more energy than reduced FAD. We'll come back to that later when we look at calculating how many molecules of ATP are made during this whole oxidative phosphorylation stage. But I just wanted to point it out to you now whilst we're talking about electrons jumping onto proteins. Okay, so we're going to leave that there today. This is the electron transport chain. On Thursday, when I see you next, you are going to look at ATP synthase and you're going to look at chemiosmosis. All right. And we'll also look at how oxygen is the last electron acceptor. But I think that's enough to take on board today. So hopefully from this lesson you have solidified your knowledge of what is made during glycolysis, what is made during the link reaction, and what is made during the Krebs cycle. And hopefully you now know where they all take place, glycolysis in the cytoplasm, the link reaction in the Krebs cycle in the matrix. And we've just started now the first stage of oxidative phosphorylation, the electron transport chain. And you now know that that happens on little proteins on the inner mitochondrial membrane. Okay, so what we've ended up with at the end of the electron transport chain is lots and lots and lots of hydrogen ions, or you can call them protons, all right, up here in this space, in the intermembrane space. Okay, right, that's it for today. Obviously I'm going to set you some work as well, but that's as far as I want to go with explaining oxidative phosphorylation to you. Well done everybody. Remember, 32 molecules of ATP for every 1 glucose molecule, not 38. Okay, and 4 proteins. All right, okay, bye everyone, well done.